Today we are going to cover 6.2 parallelograms. You guys will be able to recognize and apply properties of the sides and angles of parallelograms and the diagonals of parallelograms as well. So your new vocab here is diagonal, quadrilateral, and parallelogram. So the sides and angles of parallelograms. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. To name a parallelogram, we use this little symbol that looks like a parallelogram. In parallelogram ABCD, BC is parallel to AD, and AB is parallel to DC by definition because those sides have to be parallel. Other properties of parallelograms are given in the theorems below. So we have these guys parallel, these guys parallel. They're made up of two pairs of parallel sides. So we have quite a few properties of parallelograms, but they help us to find lengths and angles and all these things. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So if we know these two sides are parallel and these two sides are parallel, we also know opposite sides are the same length. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So if it's parallelogram, the opposite angles have congruences. If a quadrilateral is a parallelogram, then its consecutive angles then must be supplementary. They must add to 180 each across like that. And if a parallelogram has one right angle, then it has four right angles. If this one's 90, then the rest of them also must be 90. And you have a parallelogram that is either a rectangle or a square. So we could prove any one of these things with an actual proof, but we're not going to. We'll just take them as true. So we have in parallelogram ABCD, we are going to suppose that angle B is 32. We are going to suppose CD is 80 inches, and we are going to suppose BC is 15 inches. Then we're going to find AD, angle C, and angle D. So AD is easy enough. AD is opposite 15, so AD is just 15 inches. We know that, how did they say it? That consecutive angles are supplementary. So B and C are consecutive, which means they must add to 180. Most of you guys would probably be able to do this in your head, but I'm going to say 32 plus the measure of angle C equals 180, and solve from there. $148, it looks like. Yep, 148 degrees. From there, to find the measure of angle D, we know that opposite angles are congruent. So you can say that the measure of angle D is just 32 degrees. All right, pretty easy, right? Let's do another one. ABCD is a parallelogram. Perfect. We know that these sides are parallel and that these sides are parallel, and all the theorems we learned hold true. So if we are trying to find AB, this side is opposite this side, so AB must be 30 units, we could say. If we're trying to find the measure of angle C, angle C is opposite over here, so angle C is simply 36 degrees. And if we are trying to find the measure of angle D, it is consecutive to A, so you just take 36 plus the measure of angle D equals 180. So 180 minus 36 is equal to the measure of angle D, which is 144 degrees. Hopefully that makes sense. It's just based on those theorems and how the sides and angles are related in parallelograms. We do have a few more theorems. This time it's based on the diagonals of our parallelograms. This states the diagonals of a parallelogram have special properties as well. So the first one, if a quadrilateral is a parallelogram, then its angles bisect each other. Remember, bisect means cut in half. So this guy is congruent, maybe, there we go, to that guy. And these two are also congruent. So if you have a parallelogram, the diagonals bisect each other and create congruent segments. We also know if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. That's because these two are congruent, and these two are congruent by the reflexive property those are. So by side, 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 these triangles are congruent in our parallelogram. So we're going to do some algebra with these ideas now. In W, X, Y, Z, this is a parallelogram. We're going to find the value of R, S, and T. So if we find R, that is this segment, we know the opposite segment must be congruent. So we have 4R equals 18. We divide by 4. This is not going to be this will be a decimal number, that's what I should say. It is 4.5 for the value of R. Then to find the value of S, I noticed that I have some S's here. Recall that if we have diagonals, they bisect each other, which means those two are congruent. So easy enough, just set a S equal to 7S plus 3 and solve. So S is equal to 3. And then for T, T is this angle here. Now here's where it gets a little tricky. Well, remember, we have parallel lines, right? So this guy, diagonal, could be our transversal. Oopsie. So we can actually say that this angle 2T is congruent to 18 by that alternate interior angles theorem. So we're going to keep pulling that one back. So we have by alternate interior angles theorem, 2T is equal to 18. And you get T is equal to 9. All right. But that wasn't too bad. Go ahead, pause right here, try them on your own, and then we'll check them. All right, hopefully you tried them. A, B, C, D is a parallelogram. Find the value of X. Once again, we have these guys. They are congruent because the diagonals bisect each other. So when we solve, X ends up equaling 5. Now if we want to find the value of K, once again, we want to look at that alternate interior angles. We have the parallel lines. We have this transversal diagonal coming in here. That means 3x plus 4 is congruent or equal to 25, so we can solve. So K is going to equal 7 when we solve. And then the value of P, maybe the easiest one we have. These two opposite segments are congruent because this is a parallelogram, so we have 2P equal to 22. So P equals 11. Alrighty. That's all for today. You're just going to use those theorems, maybe pull back some old stuff. Otherwise, have a great afternoon.